Hello guys, in the last video we have seen the combination of two SHMs, the combination of displacements of two SHMs. We found out what is the magnitude of resultant displacement, what is the direction of resultant displacement, rather than direction, what is the initial phase of the resultant displacement. Okay, and we had x1 is equal to a1 sine omega t plus alpha 1 and x2 is equal to a2 sine omega t plus alpha 2, and we found out the magnitude of resultant displacement to be root over a1 square plus a2 square plus 2a1 a2 cos of alpha 1 minus alpha 2. Okay, now let us consider some cases. Okay, now the first case is if they are in same phase, if the phase of displacement or initial phase of displacement 1 and displacement 2 it is same, so that means my phase difference is 0, so alpha 1 minus alpha 2 is equal to 0. That means cos of alpha 1 minus alpha 2 is equal to 1, correct? So what do I get here? For my case 1 here, case 1 I'll write here, okay, and my resultant becomes a1 square plus a2 square plus 2a1 a2 into 1, right? And that is nothing but a1 plus a2 whole square, and then square root of a1 plus a2 whole square is a1 plus a2, correct? So if they are in the same phase, my resultant would be sum of the two, correct? Now second one, if instead of this alpha 1 minus alpha 2 over here it is 0, if it is pi by 2, okay, they are out of phase. Okay, so alpha 1 minus alpha 2 is pi by 2, the phase difference is pi by 2 radian. Then what happens? Now cos of pi by 2 is 0, isn't it? So my r is going to be equal to, so this part will become 0, and what you are left with is only a1 square plus a2 square under the root sign. So r would be equal to root over a1 square plus a2 square. Now what if they are opposite, they are in opposite phases? Okay, that means my alpha 1 minus alpha 2, instead of 0 or pi by 2, it is equal to pi. Okay, so my case 3 here, okay, alpha 1 minus alpha 2 is equal to pi radian. Then what is cos of pi? Cos of 180 degree, it is minus 1, correct? So then this part becomes minus 1, and the terms under the root sign would be a1 square plus a2 square minus 2a1 a2, that would be equal to a1 minus a2 whole square, and my r would be a1 minus a2, right? So when you have both the displacements with the same initial phase, the resultant amplitude will be sum of the two. If they are opposite in phase, then the resultant amplitude would be difference of the two, and if they differ in phase by pi by 2, then the resultant would be this root over a1 square plus a2 square. But now here, if you think of case of equal amplitude, okay, now if the amplitudes are equal, here my r would be equal to, now I'll use this blue pen here, and if the amplitudes are equal, then r would be equal to 2a. Okay, a1 is equal to a2 is equal to a, correct? So my r will be equal to 2a. What happens here? My r becomes root 2 times a, root 2 times of a, correct? What about this? In the third case, my r is going to be equal to a minus a. Won't it be 0 here? Correct? So if my phase difference is pi and if the amplitudes are equal, then my resultant amplitude would be, or resultant displacement at that point would be equal to 0, correct? Here it will become double, here it becomes 0, correct? And what about here? It is root 2 times the original amplitude. So these were the cases of amplitude of resultant SHM and the cases of equal amplitudes. Okay. In the next video we are going to talk about simple pendulum, simple harmonic motion of simple pendulum. Thank you so much.